So yesterday we multiplied and divided rational expressions. Today we're adding and subtracting. Okay? Remember when we're adding and subtracting just regular fractions, what has to be the same? The denominator. Same thing happens with the rational expression. So in order to add or subtract them, the denominators have to still be the same. So if the denominators are not the same, you cannot add or subtract. In order to get them to be the same, if they are not, you have to find the least common multiple or the least common denominator. It's the smallest number that's a multiple of both of the denominators. So to find what we're going to do is we're going to factor. Factor the denominator. Remember, factors like uncoiling, undistributing. And then find each factor the maximum amount of times. Get it up here. So example, we're going to work with just regular numbers here. And just regular fractions. So since the denominators are not the same, we have to make them be the same. In order to do it with the least common denominator, we're going to factor them. Okay, so 60. Or no, we want to factor out 60. So we want to pull out all the prime numbers. Okay, so the one I start with is 2. We pull out another 2. We pull out another 2. No, what else can we pull out? 3. 3. What else? 5. Okay, because 5 times 3 is 15. 15 times 2 is 30. 30 times 2 gives us 60. Okay, so we factored it all down into front. You could have done a little tree.
Factors are fast.
Alright, now let's do 54. Can we pull out a 2? That's the easiest part, I think. Can we pull out another 2? What's 54 divided by 2? 20, yes. 27.
3.
So we got 3 and 3. Another 3? Because 3 times 3, 9. 9 times 3 is 27. 27 times 2 gives us actually 52. Okay, so once you've factored them, then we're going to look at each of these numbers and figure out how many times, the maximum amount of times it appears in each number. Okay? So in this case, 2 appears twice up here. It only appears once, so I'm going to say, well, I've got 2 2s. Okay. 3 appears only once up here, but it appears 3 times down here. So we go 3, 3, 3. Okay? Last numbers are 5. It only appears once up here, nothing down here, so we're going to get 5. Okay, so I found the biggest, the most amount of times it appears in each number. Does this make sense so far? Okay, so then let's multiply. 2 times 2 times 3 times 2 times 3 times 5.
Why didn't they teach us this earlier?
I tried 40.
Well, that's the one. Why didn't they teach us this earlier?
Why didn't they teach us what
This.
this?
Yeah,
We haven't done this before.
I know.
Yes.
Why didn't they tell us this? Like when we were in middle school, when you had to like guess.
Oh, with the least common multiple? Yeah. Probably never remember, but yeah, we totally did that.
That was never.
Yeah. Alright, so 540, this is our new denominator. Okay, this is our new denominator. So, what I would do is I would write off over here. So we've got 7 over 60. We're going to somehow take this times something to get 50 or 540 on the bottom. So 60 times what gets us 540?
9 over 9.
So we're going to take it times 9, 9. So 7 times 9 is... Okay, so this is our new fraction. Okay, now let's do it with 7 over 54. Right, that's easy. So times 10 times 10, 4 times 10 is 40.
Why were you getting that?
Because 540 divided by 60 is 9, so 60 times 9 gets us 540. Alright, so now our denominators are the same, they're both 540. That means we can add our numerators with 63 plus 40. So we get 103 over 540.
That really is confusing.
Now, if it was a shorter and even number, would you have to reduce?
There's a shortcut way, maybe working with regular numbers, like regular fractions, but this is the way you have to do it when we're working with the polynomials. Sorry, I what was the question?
Would you have to reduce if you could?
If you could, yes, but I don't think you can reduce this one.
Would you ever be able to? Oh, yeah.
And when you're working with the least common multiple or denominator, you shouldn't have to do any simplifying technique.
You're gonna break your back.
All right. So keep going. So we're going to do the same thing. Example 1 asks us to find the least common multiple. Math challenge. Okay. Least common multiple of each set of polynomials. Okay. So we're going to do the same thing. So we're going to factor each thing. Okay. Yeah, we can do that.
So we don't have 6, not 16.
We factor this guy into what are the prime numbers that get us 6? 3 times 3 times x times y. All right, let's do 15x squared. What do we break him down to?
5, 3, 2x.
All right, and then 9xy to the 4th breaks down to.
Oh, writing this so confused.
Okay, I'm just breaking it down. Matt, just factoring it out.
Oh,
That's
this
all
is
we're
so
doing.
big.
This is gonna take a while.
I'm trying to get like 2 problems.
All right, so now we need to look and see the biggest number of times each number or variable in this case appears. Okay, so we've got 2. How many times does 2 appear? Just 1 time. Okay, then we got 3. What's the biggest?
1.
2. Each number. 2. So we have 3 and 3. All right, then we've got 1, 5. How about x's? 2. And y's? So that would be our least common denominator, or least common multiple.
Oh, that's all?
That's it, that's all I want to do now.
Wait, how did you get back to 9?
Oh my god, this is like
It's 2 times 5, 3 times 3 is 9.
Can we do the last one?
No,
Actually, this is going back to algebra.
I know what you said. Okay, Matt, you understand how we got these, right?
Yeah.
I cannot talk over everybody else's chit chat. Close your mouths, please. Okay, Matt. After we got this out, then we're going to look at each one and see which one has the times each number appears. That's it. Okay, so here, 2 only comes once. So put 2 here. 3 appears here and here and here, but here it goes twice. So put it twice.
Oh, I get it now.
All right, so we're going to find each thing, how many times it appears, the biggest number of times, put that down, and then multiply everything together.
Okay.
Okay? All right, let's try B. So I'm going to factor this first one. Hopefully factor that. Wait, factor it. Y times Y.
Can we square y?
No, because we've got additions here. We can't just break it apart to get over there. I'm going to factor that thing.
Not fully.
Oh my god.
Okay, let's look at it. Out of these 3 terms, what can we divide everything by?
Y squared.
We can take out the y squared. So let's do that first. So we got y squared. What do we have left on parentheses?
Y squared.
Y squared.
Well, now we can 15.
All right. Yeah, now we can unfoil, right? We can factor this part. You know, it's been a while since we did factoring. Okay, y.
Y plus 2 plus
Alrighty. We can break it down any further. Break up this other set.
From the book there is this.
Minus 8y plus 5.
So we broke it down. Now you can see the maximum amount of times each thing appears. The only double we have is y plus 5. So we just multiply everything together. So we'll have y squared times y plus 3 times y minus 8. And it only appears once, so y plus 5. All right, you need to do the next couple examples. Do you feel okay? Good. Can we move on?
Why do you put the same ones together?
Why do I put the same ones together?
Y plus 5.
I don't understand.
So there's 2 y plus 5? Yeah.
There are, but like over here we had a 3 and a 3 and a 3. I only want it once. It only appears one time in each.
Oh, yeah. Oh, okay. Right.
Should we do example 2?
Yeah, we're going to go on to example 2. Unless you guys want to do B and C. Alright. Okay, that's to simplify. Notice that we are adding. Notice we're adding, so that means that our denominators have to be the same. In order for them to be the same, we have to find the least common multiple, just like at the bottom. So if I'm looking at the bottom, we've got 2x to the third and 8xy squared. Since everything's just multiplied, it's just a monomial, we can just break it apart like we did on part A. Because there's no adding or subtracting. We don't have to worry about unfoiling. Okay, so how can I break this guy apart?
2 and 3 x's.
Okay, and how about 8?
2.
X and then y.
Okay, so what is our least common denominator?
8x cubed plus squared.
Everybody agree? No? Here's some no's?
8.
8?
8. 5.
Oh, she's good as that.
Yes.
Everybody agree now? Yep. Alright. So, now we're going to take this as our least common denominator, and we're going to say our first fraction, 3y over 2x to the third times something over something, has to get me our 8x to the third, y to the square. Here we go.
8y squared.
It's a-
Times 4y squared. How do you know that? Do you just guess?
Yes.
No, you do a guess.
Portion of it?
No, we can't do it. So what we're doing is we're saying, okay, 2 times what gets us 8? Well, 4. And then we've already got x to the third, so we don't want to take any more x's. But we have to get a y squared, and so we can take it times y squared. Alright, so then 3 times 4 gets us 12. Y times y to the squared is y to the third. So that's our first fraction. Okay, now let's do our next one. Okay, so if I want to get 8x to the third y squared, what do I have to take it times?
X squared.
X squared. So it's nice and easy. So we're going to have 5x squared is equal.
Is that right?
No, because it has us to add them. Okay, so our denominators are the same. They're both the x, or the 8x to the third y squared. So all we can do is add the tops and the numerators. So they're not like terms, we can't put them together. So we'll just have 12y to the third plus 5x squared z all over 8x to the third y squared. They're not like terms, so no. That's it. That's all we do.
That's funny.
I didn't say it was super fun. Okay, any questions on what we've done so far? Alrighty. Do you want to do B or do you want to move on?
Move on.
Move on, because B is exactly like what we just did. Alright. Next one, simplifying. Same steps, same thing as what we're doing, except since they're not monomials in the bottom, we're going to have to do either undistributing or unfoiling. Okay? So if I look at this first one, how can I factor 6x minus 18?
Take out 6.
Take out 6. Undistributed. So what do you have in the parentheses?
X minus 3.
All right, let's do our other one. How can I factor this guy?
No.
I'd take out 2 first. Right? Okay, then what? Two x and x. 6 and 1. 6 goes here or here? Negatives. Does that work? Should we switch it? Let's
Oh.
see. Got 2 and 6.
Never mind, I put 2's on both sides.
Alright. What do you think? No solution. Right here? Does that work?
I'm confused. Why'd you take out the 2?
Because they're all divisible by 2.
Oh.
This doesn't work either because we'll have 3, 2. That doesn't make sense.
Maybe the black
Is it the way around?
Yes, 2 boxes.
Yeah, it's opposite there, and it's one with 3.
Does that work? Yeah, so we got 1 and 6, which gives us this. So this one. Okay, so now we look and see, do they share anything in common?
X minus 3.
X minus 3. So we only have to write it once. Everything else we can pull out. Oh, we can break down our 6, yeah, because we can take it to, so 2 and 2 only should appear 1 time. So we'll have 2 times 3, which is 6. 2x minus 1 and x minus 3. We are least common denominator. Okay, is anybody confused on what we did?
So we can write 6. We don't have to write 2
Is
times.
that all we do?
Right, you might 6 times.
We're not breaking after that.
Yeah, we're not done yet. If it asks us for least common denominator, yeah, that would be done. But it asks us to simplify, it wants to subtract. And remember to subtract fractions, the denominators have to be the same. This is what we want the denominators to be. Okay, so we want it to be this. Easiest way, instead of going back to where we started, like I did here, I would take what we factored already, because it's a whole lot easier to see what we need to multiply by to get over to this guy. So we'll have 2 times 3 times x minus 3. And then we just look and see what's missing. So what's missing to get from here to there? What do we have to take it times?
2x minus 1.
2x minus 1. So you already got x minus 3, and we've already got 6, so just take it times 2x minus 1.
Wait, what is the other?
We're trying to figure out what to multiply by to get this denominator. Alright, is anybody confused on what we just did? Does this make sense? Alright, so then we just multiply through, so it's 5 times 2x minus 1. Alright, so that's our first fraction. Now let's do our second fraction. So again, instead of going back to the 4x squared minus 14x, blah, 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 I would take the factored form, because it makes it easier to see what's missing. Okay, so what do we multiply by? Just 3, because we've got 2x minus 1. We've already got x minus 3, so 2 times 3 will get us 6. Okay, now be careful because we are subtracting. We're not adding these fractions, we are subtracting these fractions. So I want to subtract these 2, so we'll have 5, 2x minus 1 minus 3, x minus 1 over 6, 2x minus 1, x minus 3. I think, yeah, those are not the same, so we can't put them together. That's as far as that goes. We could actually simplify it in a little bit. Because if we distribute and then combine like terms, yeah. So 10x minus 5 minus 3x plus 3 would get us what?
7x minus 2.
And then our denominator stays the same, it doesn't change. So it's not that hard, it just takes a little bit of time, and I know there's a couple different steps in there. It's not that hard. It's the same steps, the whole thing.
You find the math hard.
Okay, do you want to do the next example or do you want to move on? Move on? Sure?
Okay. I need the plus 2 number. Stop it. It's not this hard. I may not take calculus.
Alright, complex fractions. You wouldn't take calculus next year, right?
What?
You would take pre-calc next year. Not calc.
It's pretty hard.
Pre-calc is not hard. It's
Calculus is hard.
calculus is hard. Pre-calc is basically just an extension of algebra 2.
I've been told that once you get used to like calculus,
Here's the, it's really not.
you can't do normal math.
Can't do normal math.
Like I know people that are like professors in math, and they say that like they do their calculator for p plus 2 is the same.
Well, I don't know about that, but I know. Maybe.
Make sure.
Okay, let's look at this one. Notice we've got complex fractions, just like we talked about yesterday when we had a fraction within a fraction and we rewrote it. Same idea, it's going to happen here. So, in order to simplify these, let's see, there's a trick to it. Okay, so we're going to find the least common denominator of all the denominators, meaning if I'm looking, I would make these into fractions as well. And looking at all of those, we can't factor them in because they're just ones and x's and y's. So our least common denominator is just going to be 1 times x times y, or x times y. Okay, because you cannot factor these denominators, 1, x, and y, because they're not factorable. It's not like it's a y squared or anything. Okay, so the least common denominator is just going to be 1 times x times y, or just xy.
Is it sort of the factors of the denominator?
Because those are the factors of the denominator.
Oh, okay. Now it makes sense.
Okay, very good. Yep, good. So then what we're going to do is we're going to take the top and the bottom times our least common denominator, so x, y. Yeah, we're going to do some cross stuff. Okay, so what is 1 times x, y? Okay, what's 1 over x times x, y?
What do you mean why?
It would be y, because 1 over 1 over x. 1 over x times x over y. We would just multiply across, x's are going to cross cancel, so we just leave it with y. So plus y over, okay, we're going to do the same thing here, 1 times xy is going to be xy. What's negative x over y times xy?
Minus x squared.
Good, minus x squared. Anybody confused on how we got x squared? Very good. Okay.
Wait. Oh, got it.
Got it? Sure? Yeah. Okay, that's our answer.
So we're not like,
Because it's no longer a complex fraction. We don't have any fractions within a fraction. It's just a fraction.
It's gonna be all. It's gonna be all the same.
Pretty much. Yeah. Pretty much. Okay, let's look at B. If I look at all the denominators, what's our least common denominator? Ooh, close. It's just x.
Whoa. Yeah.
Because if I look, okay, the factors of 1 are just 1, factors of x is just x, factors of y is y, factors of x is just x, but I only want 1x.
oh, gotcha.
Because I don't want it twice.
So it's not twice on one side. That makes sense. We don't have to do this.
You got the numbers?
Like at the bottom, at the bottom are.
I mean, I know that.
So,
Right. All right, so then we just take the top bottom times, in this case, x, y again. What do we end up with?
X1 plus 2y or 3x minus 4y. Is that your answer?
Can you reduce it to
So we're not trying
Reduce
to,
the two y.
is it 2y or y?
Oh, you mean like cancel here?
Yeah.
No, because there's an addition and subtraction.
They're both addition.
Nope. If they were multiplication, yes. But if they're addition or subtraction,
I calculate 9 and 9.
This is, yeah, can we do, here's just,
D and C for that.
all right, let's look at C and we'll talk about least common denominators. Okay, so I'm looking at all the denominators. So I'm looking at D, C, C, and 1. Okay, what are the factors of D? Just D. What are the factors of C? Just C. What are the factors of C? Just C. The factors of 1 is 1. Okay, the most amount of times C appears is once. Most amount of time that C appears is once and 1, which really doesn't affect C. So that's our least common denominator. Does that make sense?
yep.